All right, let me just get started. So here is a quick agenda for the day. So what we'll do is, I think probably you might have heard this 1,000 times in this conference or even other conferences that you've attended in the past on AI. We'll talk about the data revolution and what's its relevance to AI. And then I'll spend some time on the hardware portfolio for AI, because this is something, of course, a lot of this portfolio of hardware, there's something that's already existing, and a lot of new hardware is getting added. We want to make sure we educate the developers on the hardware portfolio. And then we'll spend some time on the tools and the frameworks for AI. I will divide this into two sections. One is with respect to the deep learning, and one is with respect to machine learning, the tools and libraries that are available on machine learning, and then we'll spend some time on the deep learning tools. And then we'll talk about the Intel AI ecosystem. So probably that's one of the reasons why we're all here. The ecosystem is really critical from an AI standpoint, and I'll just touch upon that, and I will talk about, I'll just summarize. We will just quickly play a video. Maybe Mayank, if you can just help me with the video.
Hospitals are producing so much data that it is extraordinarily difficult to provide the analytics of it so that we can actually benefit patients going forward.
We're collecting a lot more data on these patients, but we're only scratching the surface of how that can be used in the sense of decreasing critical illness. There are always better ways for us to improve the outcomes.
And so artificial intelligence allows us to take information from tens of thousands of patients in order to predict what's going to happen to this particular patient and to prevent it from happening.
Okay, thank you, Mayank. Just switch back to the PPT. File number 5. Okay. So data, that's the new oil. So let me have a quick show of hands. How many of you have a Geo connection here? Geo, Reliance Geo. Okay? Okay, the reason why I asked this question is, it's very important from the data context. Before Geo was introduced in India, the mobile data consumption for India, we were ranked somewhere in the range of 150. And any guesses how it turned around after the introduction of Geo? We are number one. We are number one from a data consumption, right? Did you know that? So that is how things are getting transformed from a data perspective. And when we talk about average internet user, I don't know how Geo figured out this magic number of 1.5 GB. Today, probably most of you who have a Geo connection, you already have a 1.0 GB of free data every day. Right? So somehow Geo figured that out probably 2 years or 1.5 years before, right? And if you look at all the other devices, a car or an airplane, so all of these is going to generate terabytes and petabytes of data. There is going to be 50 billion devices that is going to get connected to the internet and is going to throw all sorts of data. The number of sensors is going to be 200 billion sensors. So today, probably I send a WhatsApp message to Mayank and he sends me a WhatsApp message. Probably all of you do the same thing. And there are some automated ways of sending WhatsApp messages. And imagine what's going to change. Tomorrow, your car is going to send you a message saying, please change my tires. Right? That's how, and then your refrigerator is probably going to say, hey, my compressor is kind of going away, right? Please replace me. So that's where the whole data revolution is happening. And that is not too far away. Believe me, it's not at all too far away. And we were actually having a meeting with one of the Reliance Geo executives, and he was telling us, hey, we are not really sure. We have a lot of data. We don't know what do we really want to do with that data. I'm sure a lot of the people sitting in this room, you're still scratching your heads to figure out what are you going to do with all this data. And I think that is where a lot of the insights, the business insights, the operation insights, and the security insights. Just to quote an incident, I don't know how many of you are aware, probably a year or a year and a half back, they figured out that, okay, there are all these cameras that are connected to the internet. They figured out that somebody hacked that camera. Where is the security for that camera? So then they figured out, oh, there is a need for a security even for the devices that are just at the edge, which is just taking videos, right? So we never thought about that. So AI is going to give us all those different insights. So with this, AI is the next revolution, compute revolution. Especially with compute, it started off with the mainframe days where we had huge machines, right, sitting somewhere in a big room. Probably this was in 1960s and 70s. And Intel, when they introduced all these servers, the x86 servers, probably somewhere end of early 2000s and 1990, 98, 99 timeframe, the server market got commoditized, right from the mainframes. Probably now you look at how many mainframes exist, probably a very less percentage. And then after that, cloud and virtualization. They felt, oh, there are all these servers. How are we really utilizing it? Are we really utilizing it 100%? Probably no. Then came the idea, oh, okay, maybe there is something, say, a concept called virtualization where you install multiple operating systems on the same server and then utilize it much better. And then came cloud, which again transformed the whole compute industry. Now, the next biggest revolution is AI, and I'm sure that's why all of you are here, right? And one thing that has been happening till date, there's been tons of research that's been going on, and what Intel is trying to do is tons of research on AI that's happened and that's continuing to happen. What Intel is supposed to do is, every transformation that has happened in the past, Intel has taken the lead, and we continue to take the lead when it comes to taking AI to the mainstream, right? We just don't want to stop at the research phase. We just want to take it to mainstream. So any guesses on what's the number of production deployments? What's the percentage of production deployments? Every single person is talking about AI. Any guess on the percentage of production deployments available today? Any numbers, please? 2%, okay, very close. Yeah, it's somewhere in the range of 3 to 4%, right? Not more than that. A lot of people are talking about AI, but the actual number of production deployments is still very, 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 very less. And that opens up a huge opportunity. So all as Intel, what we want to do is basically take that to mainstream and take that to production, right? That's what we want to do. So now, I'm sure you probably have heard enough definitions for artificial intelligence, deep learning, machine learning. I just want to use one simple example. How many of you have kids here? And how many of you watch cartoon along with your kids? So there is this famous cartoon called Doraemon. Any of you know Doraemon? Oh yeah, wow, okay. So my daughter was asking me, she's 9 years old. She asked me, you keep talking about AI. What is AI? So then I thought, okay, I was just watching the TV along with her, and this Doraemon had this wonderful device. This kind of gives all these wonderful devices, and this device was like predicting exactly 1 hour from now, there is going to be a big disaster that's going to happen, in the next street. So I said, I told my daughter, hey, this is what is AI, right? It's actually predicting what's going to happen in the future. And then she called it, oh wow, that's interesting, right? Even though she's able to relate to the concept. So just from an Intel context, I would just want to use an example to articulate what artificial intelligence is. So of course, Intel is close to my heart, been here 15 years. And I'll take the example of a fab where we manufacture these CPUs. So let's say we have a lot of data in terms of all the yield. When you say yield, how many CPUs get out of the factory day in and day out. So there are n number of parameters that affect this factor of yield. So when we have to calculate, hey, what are the factors that actually affected the yield? We just have to pull a lot of historical data and visually, and if somebody has to do that math, sitting, it's not going to happen. So we just throw all these data to the machine, and all that it's going to do is do some number crunching and then say, hey, this is what it is. These are the factors that exactly influence your yield. Okay? That's a very high level, that we can use AI, meaning we can just correlate that to AI. So now it comes to machine learning. So I want to be able to predict what is going to be the yield of these, how many CPUs get out of the factory in, let's say, the next 1 month. Okay? So now what we do is, again, we start collecting all these different data. We run some data analytics, and then we make sure, hey, we run a lot of machine learning algorithms, and then figure out, oh, this is exactly going to be this kind of correlates the Doraemon example, right, where you're going to predict. So that is the next level. We're going to predict that, oh, this is going to be the output in, let's say, for the next 1 month, and that is actually going to drive a business decision. So how many CPUs, I have to keep my supply chain ready. I want to make sure that my sales force is ready and I tell them, hey, this month you are only going to get this much supply of, let's say, a Pentium CPU or even a Core CPU. So make sure you play your cards accordingly, right? So that's what machine learning is going to help. Now let's take it to the next level, the deep learning. So millions of CPUs get out of these fabs day in and day out. I want to really figure out how many defects are there as part of this the cycle, right? So that's where deep learning comes in. There's some vision, there's image processing, there are some deep learning algorithms that comes in, neural networks, all of this come in, right? So I just thought, just explain AI, ML, and DL in this simplistic context so that you can correlate to that. So with this, I just want to move to the AI hardware portfolio. So now, when it comes to the hardware, I'm sure probably a lot of these CPUs that you see here, the Xeons, the Core, and Atom, it's nothing new to you, right? Anyone who's not aware, probably we need to have a separate session. Okay, so when it comes to that, let me just divide this into training and inference. So if you look at training, even though today training happens a lot on the GPUs, all of you know that the GPU is sitting on a Xeon, and we'll also talk about how much of a GPU is going to be helpful when it comes to artificial intelligence, when it comes to training, right? So this is something that's already existing, Xeon. You can just straight away take that and use it for training. Now, when it comes to intensive workloads, right, there's something that, this is Nirvana. Nirvana is a company that Intel acquired I think 2 years back. And they have specific accelerators that are targeted for training. And this will come out by the end of the year or early next year. Right? So this is specifically, if your Xeons are not good enough, you need specific accelerators, then that's where you go with this. We call it, it's called, we have internal code names, but it's coming out in the 2019, end of 2019, 2020. So now, coming to inference. So okay, let me ask you this question. How many of you right now, sitting here, how many of you have a device that can do inference? Okay, I repeat the question. How many of you in this room have a device, whether in your pockets or whether in your bags, that can do inference right away? Everyone, right? Everyone has a laptop or a phone which can do inference, say any device, right? It could be a drone, it could be the device which has any of these CPUs, right? Atom and Core, it can do inference. So that's one thing that's at a very, very high level. If you want to just do normal inference, that's just good enough. If you say that, hey, I have specific workloads, and I have some specific vision requirements, that's when you have these different accelerators. So we start with FPGAs. We acquired a company called Altera 2 years back, so that's coming from there. And then MoviDS. How many of you are aware of MoviDS? So maybe I will just. So this is the MoviDS stick, right? So this is just going to fit into your USB drive, and then you can offload all your vision processing to this unit. If you think that your CPUs are not really doing the job good enough, then especially from a vision standpoint, you just plug this into your USB port, and then you're just good to go, right? And so that's where we have a lot of these. One is the FPGAs, one is MoviDS, and we have the GNA, which is for speech processing. So we have all these different accelerators, specifically if your CPUs are not good enough for the workload that you have. Okay, so just want to say that one size, of course, does not fit all. So you just need to make sure what is your workload. I think our friend from Microsoft also spoke about some of these customizations that, depending on your workload, there are things that are going to change. So that fits exactly the hardware story as well, right? So now, talking about where each of these fits in. So if you look at a Core and an Atom, it's going to be all here, right? Your laptops, your drones, your cameras. Probably your cameras will have a MoviDS chip in it. Your laptops will have either a Core or an Atom or a Pentium Celeron. Your let's say your drones can have a VPU, or we call it the VPU. MoviDS as a VPU, which is vision processing unit, right? So these are the endpoints where actually inferences happen, right? So and then I did touch upon that in the previous file as well. So what is edge? Edge is nothing but a gateway. A lot of times we don't really have to push all the data to the cloud, because one is, of course, the latency requirements, and also in terms of utilizing the bandwidth effectively, right? Do you really need to, we have so much of data, do we really need to throw everything to the cloud? Probably not. So that's where we use gateways, which is nothing but a Xeon server sitting inside a small, let's say you have an organization of 100 odd people, maybe like let's say 1 to 10 Xeon servers sitting inside the campus that can just do this job. If you talk about a car, okay, the day is not too far, and of course, if you are driving an autonomous vehicle, for all reasons, you will have something like a gateway that's sitting inside the car, because you cannot wait, for the cloud to respond, and by that time, you already hit a cow on the road, right? So you cannot wait that long. So there is going to be a small mini server that's going to sit inside the car, which is essentially going to help you do some of the number crunching, right? So that's the edge or the gateway we call, and of course, data center and the cloud. I think that needs no explanation, and all of you are probably aware of, that, okay, if let's say the data is huge, you cannot really afford to store it locally, and of course, if you want to do compute just on the go and in time, right, you basically use a cloud to do all the processing, okay? So this is what I have from a hardware standpoint. Okay, this is a very interesting question. Okay, let me, again, quick show of hands. How many of you use a GPU today for AI? Quite a few. So what would you answer for that question? Yes, okay. All of you, yes? Okay, that's actually true. Right? For most part, if you look at the training aspect of it, maybe, it's the high-level view is that the time taken to train in a CPU is so much, and a GPU is just this much. And the GPU fans agree with that? Yes? Okay, fantastic. Now let's look at this. Okay? So now on a CPU, of course, the data preparation, because you are used to CPUs, the amount of data preparation time that you're going to spend is going to be significantly lesser, even though the training is going to take much time, right? Much more time than a GPU. And your POCs may last somewhere between, let's say, 4 weeks to a year, right? You spend a lot of time preparing your data, and then, of course, training, and then you do some validation, and then, of course, in this case, the CPU basically continues to run. So here what you do is, of course, you do prepare data. You actually spend more time. You actually spend more time preparing the data for the GPU. And then the training, of course, the GPU finishes in much faster and in this smaller time. And of course, you will do the same validation. And then, of course, the GPUs continue to remain idle. And you are investing so much money. Yes, okay, we will come to that, right? So essentially. So here the message that I want to, of course, right, when you're doing a proof of concept, right, you just have to look at the overall picture and then make a decision. I'm not here to say, oh, you have to use a CPU or you have to use a GPU. And of course, today, some of the cloud providers do have offerings with the GPU, without GPU, and all sort of instances, right? So you can wisely decide based on the workload, based on the exact scenario that you have on hand. Okay, I'm not really dictating terms. You should use, of course, I'm an Intel fan, you use a CPU, but you can decide that for yourself. Okay, so I just want to leave with this thought. Be smart and take your own calls depending on the workload that you have, right? All right, so now hardware without software is not going to take us anywhere. So what I will do is spend some time and just for some statistics. In Intel, in Bangalore, 40% of the people who are working are software engineers. Okay, so software, meaning Intel is investing heavily, meaning the reason why I'm here is, of course, Intel has invested some money in software. And we believe in educating the developers and making their life easy. How can Intel, we can make their life easy, right? So that's where we will talk about some of these tools and libraries. I will talk about a few tools from a machine learning standpoint. The first, we'll talk about 2 tools from 2 libraries or packages from a machine learning standpoint, and then we'll switch over to deep learning. All right. The first one that I will talk is Data Analytics and Acceleration Library. So that's DAL. I know DAL is part of our life, isn't it not? But not this DAL, though. So the idea of this library is that I will pick the same example of the factory and trying to understand the yield and all that, right? I would take the same problem. So if you look at that problem, what you do is do all the data collection, and then you do a lot of pre-processing, clean up the data and all that. So that's the first step. And then what you do is with that data you do some transformation. And so what DAL offers is at every stage, right? You visualize the data, and then you create models out of it, and then you validate it, and then the decision making happens. For every stage of the pipeline, DAL provides you APIs that you can use, and which is already optimized for Intel architecture, irrespective of the hardware that you are running below. Right? We just speak about a bunch of hardware, right, from Xeons to MoviDS to FPGAs to all of those is abstracted, and it just gives you the best performance. Just you just use this library, and it's going to make the best use of the hardware. Okay, so that's about DAL, and of course it has interfaces for Python, C++, and Java, and of course for Spark and Hadoop as well. I did hear a question on Spark and Hadoop previously, so there is support for that as well. Right, so this is the first library that I wanted to show. The next one is on Intel distribution of Python. So how many of you are using Python today? All of you. And how many of you are aware of Intel distribution of Python? Okay, glad I had this foil today. Okay, so I see that less than 5% really know that Intel has its own distribution of Python, which is well optimized for the hardware that's lying underneath, and it is just free for commercial use. Right, so I just wanted to let you know. So all of your NumPy, SciPy, scikit-learn, all of these are already optimized. And we use something called MKL. Any of you heard of MKL? Yes, math kernel library. So these are libraries that have highly optimized mathematical routines, sometimes even written in assembly to utilize the hardware features. Right, so DAL underneath will basically use MKL and make sure it accelerates your performance. Right, and then of course with PyDAL we also interface with DAL to make sure we take the goodness from DAL and accelerate the whole process. Okay, and of course it's available from Conda, and then it's again whenever changes are there we upstream back, and all the goodness is available to you. So what I will do is I will just break now for a quick demo from Mayank on Intel distribution of Python just to see the performance. Mayank, why don't you start?
So am I audible? No?
Yeah.
So now? Yeah, okay. So what I'm going to do is I have a code with me. It's a k-means clustering code. And I'll be running that code using the stock Python distribution which I have in my system, and with the Intel distribution for Python. So I just want you to focus on these lines. So if you see here, currently the version in my system, the Python version in my system is, I think it's visible, it's Python 3.7.0. It's the stock Python version. And then I have this folder where I have my demo, Python demo folder, and I have opened Jupyter Notebook from that. So this is the code here. I will just run the code, and while it is running, I will just explain like what the code is all about. So we have some import statements, and so if you want to like be sure that I am not running Intel distribution for Python, one thing which we can do is, so there's a section in the code which imports DAL optimizations in scikit-learn. So because DAL is specifically in Intel distribution for Python and it's not part of scikit-learn from stock Python, if I run this portion of code, you can see that there's an error because stock Python doesn't recognize DAL. Now, some import statements, you can see that I'm using scikit-learn, NumPy. So as we claim that in Intel distribution for Python, we have accelerated these packages, and how we have done that. So underlying NumPy, SciPy, scikit-learn, all the calls, they are done in MKL and DAL. And especially the native codes are used, C, C++, and assembly codes are used. And we come out of Python environment for some time. We do our computations there, and we get back to the Python environment. And you can see that in this code, it's taking quite a while to run. So this is the k-means clustering code. You have a you have n data points and you want to cluster them in so here I have taken the colors to be 8. So actually this code is you have an image of some 96,000 plus colors, and we will be quantizing that images to 8 colors. So okay, so it took some 39 seconds for this code. I would just go ahead and show you how the output looks. So this is the original image. This is the quantized image when you apply the k-means. And this is the image you get if you just choose 8 random colors. Now, what I will do is I will activate Intel distribution for Python. I just want you to remember the number. It took some around 39 seconds when we were in stock Python. You will also see like how easy it is to switch between different Python versions. If you have so I was earlier having the stock Python version. Now what I will do is I will just activate Intel distribution for Python. For that, all you have to do is run a script called activate.bat. Once you do that, now you can check the Python version. So it gives Python 3.6.5 from Intel.
So is the color visible at the back? Is it okay? Maximize it. Can you maximize it? Yeah.
And then from here I am opening the Jupyter Notebook. I hope Jupyter Notebook picked up the correct Python version, because sometimes it messes up with that. So for that, usually what I do is I run the Jupyter Notebook, which is provided within the Intel distribution for Python itself. So IDP, Intel distribution for Python, also comes with packages, these tools like Jupyter Notebook. So you don't have to get them. And yeah, so definitely we are in IDP. That can be confirmed because in that code we were not getting this warning. So this is a warning here, not an error. And it shows that the SciPy, so the versions of SciPy in both distributions of Pythons are different. So that's why it is showing some warning. And you can see that the same code is now taking some 2 seconds here. So sort of a 20x performance you got when you are using Intel distribution for Python. I can also explain you how you got this sort of 20x performance. So because I am essentially using two logical cores in my CPU, and the underlying instruction set is AVX2, and from that I am getting some 8x performance. I am not going to tell you the mathematics what is going on, but that 8x and 2x gives you 16x, and some software optimizations take you to 20x performance improvement, which you get if you are using Intel distribution for Python. So if you are having codes where you are doing where you are using NumPy, SciPy, scikit-learn, and those kind of stuffs, you can get Intel distribution for Python. Getting it is easy. So this is the home page for Intel distribution for Python. All you have to do is go to software.intel.com/ or you can just do a simple Google search, you will be there. And here are some packages which you can see, like what are the offerings from Intel distribution for Python. So it's just that you use a different version of Python. You don't have to make any code changes. Code remains the same, everything remains the same, and you are getting out of the box performance improvement just because you are on Intel architecture. So I think one should definitely try this. If you are on other hardware, we expect it will perform in the same manner.
Meaning we may not really degrade the performance, but at least it should be on par. Okay. So yes, go
So
ahead.
to use Intel distribution for Python? No. So it's just like another Python distribution. You can use any Python distribution on any architecture. Similarly, you can use Intel distribution for Python on any architecture. No, the only thing is the only thing is there are the versions supported are 2.7 and 3.6 as far as I'm. So if you are in these versions, then you can definitely go for Intel distribution for Python. So these are the accelerated
Optimized.
packages. Other packages are also there. So it's not the case that some Python package is running on stock Python and it will not run on IDP. IDP is sort of a superset of whatever you are getting in stock Python.
Yes.
Yes. Yes.
Yeah, using MKL and DAL, right? So
So I will just take a minute. I will just shamelessly promote our tool here. It's called VTune, Intel VTune amplifier.
probably that answers your question.
Yeah. So here what I have done is just analyzed this code. I have done, so the same code I have, so for the first, I will just, okay. So for the first code, I have used the normal Python exe from Python 3.7. And for the second one, I have used the Python exe from Intel distribution. So you can see in these lines. And if you see the, so here what we get to know is like what are the function calls, how much time each function call is taking and all those stuffs. So if you see, this is the analysis for the Intel distribution for Python version. And here you see that the underlying libraries, they are coming from all of them are coming from these DAL, or somewhere if you look, probably you can find something related to MKL also. And when you do the same for the same bottom up for the normal Python distribution, you will never see these DAL or MKL stuff here. So what exactly is going on is we are coming out of Python environment for some time. We are performing our computations in native codes, and then we are going back to Python because Python is inherently slow. So because of that, we have done some optimizations, and those optimizations exploit whatever the hardware offerings are there, and thus we get the
Okay.
performance.
In the interest of time, probably we'll have to move on. Thank you. Thanks so much, Mayank. Okay, so now we'll move on to the. Can you just. Okay, all right. Just had the demo. So now let's move on to the tools that are relevant from a deep learning standpoint. So I did touch upon MKL as a library. So now, especially for deep learning, MKL needs some of the additions. So if you want to do direct the convolution, LRN, so the normal MKL does not support. And MKL DNN, of course, it's an open source, and this is the library that can be used or leveraged for deep learning. Right? So the thing is, again, even the usage of MKL DNN is abstracted to a great extent, because I will talk about that in the next foil, right? So. So optimized deep learning framework. So I just briefly touched upon MKL DNN because you just need to be aware that there is something that exists that is called MKL DNN. But the reason is that now, if you look at all these frameworks, maybe a quick show of hands, TensorFlow. Okay, Caffe. Maybe less. Okay, so majority of you are on TensorFlow. So right, so what we have done is taken the base TensorFlow, and then we have basically have a version of TensorFlow that is again Intel optimized. And how is the performance coming? It's coming from MKL DNN, right? So so the Intel optimized version of TensorFlow is again utilizing the MKL DNN libraries and making sure it accelerates the performance, right? So all that you have to do again is just go download the Intel version of TensorFlow, which can just run seamlessly, irrespective of the hardware. Of course, optimized for CPU, right? Optimized for CPU, and then you get the performance. So all of these different frameworks are optimized by Intel. So we are spending a lot of effort in optimizing all of these frameworks to make sure it runs best on Intel. One thing that I want to touch upon is these are, again, coming from different vendors. Big Deal is one such framework that's developed by Intel, and that's specifically for the Spark clusters. The reason being, we saw a gap there in terms of, especially there's a lot of data that's lying in your Hadoop clusters and Spark clusters. We want to make sure that how can we really utilize the data and run in a distributed fashion, run training on a distributed fashion, right? So that's what big deal is all about. And we also have this, you see this small n, that's called the Neon framework. So that's again a framework developed by Intel, mostly for research purposes. So these are all the different optimized frameworks that utilize MKL DNN, and it gets you the best performance. Okay. So now, before I move on to the next one, any questions until now? Until we spoke about MKL DNN and yeah, we kind of, we are also catching up, right? Because we have to focus our energies on, because as you saw, majority of them are on TensorFlow, right? So that's why we started off with TensorFlow, and all of these are in progress, right? So that's the whole idea. All right, okay, now. Okay, OpenVINO. How many of you have heard of OpenVINO? One person, okay. All right, I see a few more hands up. So maybe, can you just expand OpenVINO if you already used it? Oh, only yesterday, okay, all right, okay. So, all right, fantastic. So, all right, I'm really proud of this tool, okay. One of the reasons is I have been in Intel for 15 years, and never has so many teams come together to deliver something like this. This is such a fantastic toolkit, which is specifically focused on vision and deep learning. And there are so many teams that have come together to deliver this. So now, OpenVINO stands for Open Visual Inference and Neural Network Optimizer. Intel is very famous for these acronyms. You see, right? DAL, OpenVINO. So we have some dirty acronyms too, which I would take offline. But some of these, this is such a good toolkit which puts together a lot of different things together and delivers a seamless experience for the developers. So what essentially is OpenVINO? It's a computer vision and deep learning toolkit at a very high level, heterogeneous execution across. So let's say if I have this MLDS stick, or if it's running on a CPU, or it's running on a, let's say, Intel integrated GPU, or it's running on an FPGA, OpenVINO just abstracts everything for you. All that you have to know is, hey, you just use OpenVINO, and you're done, right? So now, why is this really important, right? So deep learning revenue, I think from a business standpoint, I know very less decision makers here, so I would probably, all of you know that, hey, from a business standpoint, vision is a big market, and deep learning is also a big market, so we want to make sure we ease developers' job when it comes to developing applications for deep learning, right? So that's the whole idea. So what exactly is inside the distribution of OpenVINO? Again, OpenVINO is open source. We have a version that's the Intel distribution of OpenVINO. And so what exactly is there? So OpenVINO has two sections, right? One is the deep learning deployment kit and the traditional computer vision tool and libraries. So I'll just focus on the traditional first, and then we'll get into the DLDT. We call that the DLDT. So if you are a developer who is on vision, I'm sure you are either using OpenCV, OpenVX, whatnot, right? So this portion of OpenVINO basically has all the optimized versions of OpenCV, Intel optimized versions of OpenCV and OpenVX. And that is how you basically get all the best performance, right? So that's one portion of it, right? So if you're on traditional computer vision, you can still use OpenVINO, just for the reason that your libraries, OpenCV and OpenVX, are all optimized, and you just get out of the box performance. Now let's look at, okay, you're into deep learning, and that's why you're here. Now you wonder, what do you do with it? What do you do with OpenVINO? So what we have is something called a model optimizer and then an inference engine. So what's a model optimizer? So let's say you have a pre-trained model that is there that's coming from a TensorFlow or a Caffe. So what you do is you basically put that into the model optimizer, and then it gives you a intermediate representation. A bin and an XML file is generated, and that's the intermediate generation, which will then utilize the inference engine. And the inference engine, what it does is it uses these files as the inputs and runs on the target hardware. Irrespective of the hardware underneath, all that you do is you just do a -D for a CPU, for a GPU, you just change the option, and then you can just get to run on it, and then experiment and see which gives you the best performance. For your workload, we probably at a high level, you may not even know which is the best, right? The CPU or an integrated GPU or a vision processing unit or the FPGA. So you don't even know that. So now you can play around with these different options, and then you can figure out, okay, this is what, let's say this is the hardware that I have, and this is my particular workload, my particular model runs best on this particular hardware, right? So it helps you explore all those different options, and then do the inference. So that's what is OpenVINO in a nutshell. So we also have a demo for OpenVINO. Again, I invite Mayank. Can you show a demo for us, Mayank?
So
Can you just maximize it if it's
Yeah.
possible?
So I have created a virtual environment because OpenVINO only supports, I guess, Python 3.6. So what we are going to do is, I will just show like what demo I am presenting. You can go and read about the demo in a lot of detail. It's a store traffic monitoring solution. It tracks of the people coming and the inventory, which is or the items which are going out of the store, and you can
It's a
read about
typical
it.
retail scenario where you walk into a retail store and then pick certain items. So all that it's going to do is track you, and then the items that you pick is going to just follow you. The network follows, right? So it's just going to follow you.
So as Ellen already told, like we make some intermediate representations and all. So I'm not going to tell a lot about those stuffs. You can just read about it and you can go through it. I will just show you the commands which are there, which you can use to run your application on GPU and CPU and all. So yeah. So this is the command which you run, and you can see that I've given the extension -d
So this was the option that I was telling you. All that you do is just change this option for between the different hardware, and you get to run it on a specific.
And you can see that so we are having multiple channels here. So the video is coming from 3 channels, and you can see that the person as well as these bottles are being counted, and the FPS you are getting is around 7 to 8 when I am using the CPU. And you can see on the task manager also that it utilizes all the cores quite efficiently. So and this this FPS is not having that rendering effect in it. So it's a sort of underrated FPS which you are getting here. Secondly, the same setup I can run it through GPU, and for that,
So again, this is Intel integrated GPU.
yeah.
Okay. Let me be very clear.
Just taking a look. Okay, let it come. Yeah. And now in this case, you can see that the workload of CPU will slowly come down. It's coming down. And if you see here for the GPU, so you can see that its utilization has been increased. And
Yeah, you have the stick. Okay.
Yeah.
So all that I do is I just insert the stick into the USB port, and I can just use a VPU -VPU D VPU. It will just offload to this particular vision processing module, right? So
in all the 3 different hardwares with just some tweak in the command line, you can get them running. So this is what you can do through OpenVINO.
okay, thank you, Mayank. That was wonderful. Thank you so much. Yeah.
Yeah. So for GPU and CPU, it was same. If I use the MLDS, it comes around 3 to 4. So because it's a lightweight sort of device.
Okay, let me answer your question slightly differently. You know that there is an integrated GPU that's there on your machine that is just getting underutilized, right? If you offload that to the GPU, probably the CPU can do something else, right? That's the way I look at it. System memory, yes. No, but it all depends on your workload, right? We cannot really say, hey, okay, what's the guarantee that it's going to kind of rob all your memory? Right? So it all depends. See, essentially, the whole idea that I wanted to give is, there is a lot of things that are existing in your current laptops and the current infrastructure that you have. How much, I just want each one of you to think, how much each one of you are really utilizing it, right? So that's the whole idea that I want to just drive in. Okay, any other questions on OpenVino? Okay. All right, so with that, of course, I will move into the ecosystem. So, of course, we have this AI Builders program, so there's 4 different verticals to it. The tech enablement part of it, of course, you have all these documentations, the videos that came, probably what Mayank just showed you, when he showed you the documentation for the Intel distribution of Python or the OpenVino. It's all out there. So this is what helps you do, get all the technical resources for AI on Intel, right? So, and then, of course, we have co-marketing, matchmaking. So in terms of, let's say, you are interested, we do have a lot of partners who are interested in joining, probably, let's say, a showcase of demos. We do take our partners to a lot of big events and conferences. It's a marketing for them as well, right? So, for example, I interact with a lot of customers who are on OpenVino, and we have seen the performance improvements as big as 200x, right? And these are showcase items for us as well as them. So we work a lot with all these different partners, and we go for joint marketing events. And then, of course, matchmaking and investment. Of course, don't come to me for investment. Of course, there are people who are paid better than me to deal with that. But of course, we do. Intel Capital is the wing which does this investment from an AI portfolio standpoint. And just to let you know, our investments have paid significantly, right? Nirvana was an Intel invested company which we bought 2 years, 3 years back. Altera, and all of these different acquisitions that we did for AI in the last 3-4 years, it's just paid off wonderfully, and we are seeing all of this converge, right? So all of this converge, and this is what essentially helps us take AI to the mainstream, right? So I just want to also, here are all the different partners, especially from India. We have Wipro, we have L&T, we have TCS, and a lot more customers out there in India. And of course, if you find Kavita somewhere, so Kavita is there. So she is responsible for some amount of ecosystem enabling in India, right? So you can talk to her. So with this, I just want to summarize. Intel has the best-in-class hardware, software, and the ecosystem to revolutionize AI. And the key thing is, of course, there's been a lot of things happening in terms of research. Our focus is to bring AI to the mainstream, right? And as a developer, you're all sitting here, of course, your day's productivity, right? It's all about productivity. And every ounce of performance matters, right? If there is something that's going to be freely available just by replacing a normal distribution of Python with Intel distribution of Python, how does it matter, right? Meaning you're getting more performance just with using the same code, everything is the same just by replacing a distribution of Python and probably Intel optimized TensorFlow, right? So all of these, with just a minor tweak in your development environment, you're just going to get the best out of the Intel hardware. So as developers, it's very critical when you are going to the market. So my ask is, hey, what does it take to make these small adjustments and get the best performance? So overall, I just want to say that, hey, hardware, software, the ecosystem, it matters, and that's what brings the value to the customers. With that, I open to questions. Yes.
Mayank, in the demo, first which you showed, can you just go and change the parameter in the k-means for number of jobs equal to -1? So I'm just trying to understand, is that the parameter optimization or is that actually MKL which is kicking in? So the first demo without Intel distribution of Python, can you just change the parameter for number of jobs in the k-means k-means object -1, which will basically use all of your CPUs parallelly?
Okay. So probably we can take this offline.
Okay.
That will be better. We can consult it.
So we can surely show you that. No problem. We can do that. Okay. Any other questions? Yes.
Hi, Mike. So my question is about TensorFlow, Intel distribution of TensorFlow. So we all saw that sklearn is almost 16 times or 8 times faster than the normal distribution or the existing distribution of Python. But have you benchmarked the same for TensorFlow? How faster it is comparison to the regular distribution of regular TensorFlow?
Absolutely. So probably I have some numbers offline. If you want to take a look at it, we can
Sure.
share that with you.
Sure. Thank you.
Sure. And of course, that's one of during our regular validation cycles and all that, that's one of the key metrics, right? How much are we able to, how much in terms of performance are we able to get compared to a normal distribution versus, let's say, Intel distribution, right, of TensorFlow. So that's one of the key metrics that we have as we go through our validation cycles. Okay, if there are no other questions, thank you so much for patiently listening for the last 45 plus minutes. Thank you so much. I hope you enjoyed it.